What's up, guys? It's Mr. Bringle, and today we're going to be talking about the acceleration concept builder from physicsclassroom.com. I'm just going to go through a couple questions from each of the trophies, and then you guys do the rest on your own. Let's start with the first trophy. So we are deciding if this object is accelerating. Now, the main thing here is that we remember that acceleration is defined as a change in velocity over some period of time. So as an equation, that comes out to be acceleration is equal to delta v, change in velocity, over delta t, change in time. Okay, so if there is a change in velocity, then there's a change, there is an acceleration. Okay, so this says a rightward moving car slows down from 20 meters per second to 10 meters per second. This car did change its velocity, and therefore it is accelerating. Does not matter if it's speeding up or slowing down. It's a common misconception that the word acceleration means speeding up. It can mean either speeding up or slowing down. It's just a change in velocity. So that's what you're going to be doing on this trophy. Pretty straightforward. It's going to give you some different types of questions like this one that's actually showing you a chart or a table of time and velocity. And we can see here that as time progresses over the course of 4 seconds, there is no change in the velocity. The velocity stays at 25 meters per second the whole time. Therefore, this object is not accelerating. Okay, now this one has a 5-second time interval, and we see that the velocity is increasing by 2 meters per second each second. So this object's actually accelerating at 2 meters per second squared. So yes, it is accelerating. All right. I'll go ahead and do this one, and then I'll leave you on this one. But this is a dot diagram or a motion map. It says that the object, the car here, is moving from left to right. So that means it's going this way. And it doesn't really matter which way it's moving. The answer would actually be the same for this. But this is indicating that the car starts over here, and initially it's not moving very fast, because remember, these are 1-second intervals in between each dot. So it shows that the object doesn't move very far after 1 second. It moves a little bit further on the next second interval, and further and further and further and further. The only way for that to happen is if the car is picking up speed, right? The only way for it to move a further distance in the same 1-second interval would be faster, or a change in velocity, an increase in its velocity. So yes, this object is accelerating. Okay. Now we'll probably go ahead and move on here. Let's see what the next question is like. So I'll go ahead and leave you on that. You guys can figure out the rest on your own. Let's go ahead and move on to the second trophy here, which is getting direction on acceleration. Now, we've talked in class about if an object is speeding up, okay, speeding up. So I'm going to say increase in velocity, the acceleration will be in the same direction, okay? So I'm just going to put accel is same direction. Okay. Now, if you're slowing down, so decrease in velocity, okay, slowing down, the acceleration is in the opposite direction. Okay, the opposite direction. And that's going to be true for any situation. So once again, it is a common misconception that a positive acceleration means speeding up and a negative acceleration means slowing down. It's entirely dependent on the direction. Okay, so if an object is moving to the right and speeding up, it is going to have a rightward acceleration. If the object is moving to the right and slowing down, it would have a leftward acceleration. But if the object was moving to the left, those things would be flipped, right? It would be a leftward acceleration for speeding up and a rightward acceleration for slowing down. So keep that in mind. Now this says a northward moving sprinter is slowing down. Since the person is moving to the north but slowing down, the acceleration must be in the opposite direction and therefore the south. Okay, it looks like I will need to let's see if I can move this stuff here. Let's not. Let's go ahead and erase it then. So we'll just remember that. But this says the dot diagram represents the movement of a rightward moving sprinter. So the person is moving to the right, which means that they are slowing down. So because of that, so the velocity is to the right. Therefore, the acceleration must be to the left to cause this object to slow down. Okay, now on this one, it is showing us that as the time progresses, the velocity is decreasing. So we're going from 10 meters per second to 2 meters per second. And it says the person is moving to the left. Okay, so if the velocity is to the left and the object is slowing down, then the acceleration must be to the right because it has to be in the opposite direction. Okay, we'll do one more here. It says an elevator is a downward moving elevator is slowing down. So the velocity is pointed down. And again, it says the object is slowing down. So therefore, the acceleration must be in the opposite direction, which would be up. Alrighty. We'll see what this next one is. Okay, I'm going to go ahead and you guys will get the idea on that. I'm going to go ahead and let you guys finish out the rest of those on your own. And I'm going to go back to the main menu and we're going to look at the third trophy, adding value to acceleration. So with this one, we do need to remember that acceleration is equal to change in velocity over change in time. And another way to write that would be that the object's final velocity minus the object's initial velocity over the time interval. We'll put parentheses around this, okay? So that's the equation that we'll be using because this is actually having us calculate the acceleration. Remember, the word magnitude just means how much. So this is the number right here. The magnitude is the number value. So if an object accelerates at 5 meters per second squared, the magnitude is 5. Okay, and then we do need to assign a direction to acceleration. So this says a westward moving motorcycle slows from 24 meters per second to 12 meters per second in 3 seconds. So if we're actually going to do this calculation, the acceleration is equal to the final velocity, which is 12, minus the initial velocity, 24 meters per second, divided by the time, which is 3 seconds. Okay, so obviously this is going to come out to be negative 12 meters per second divided by 3 seconds, which is going to be equal to negative 4 meters per second squared. Okay, so the magnitude here is going to be 4. Okay, now the direction, we really don't even need to include the negative sign here on the 4 because we're going to assign the direction. It says that it's moving to the west and it's slowing down, so we know that the direction of the acceleration must be to the east. Since it's slowing down, direction must be opposite. We learned that in the last trophy. So we can put 4 meters per second east, and it actually does tell you right here that you do not need the negative sign. So we can leave it just like that. Okay, we'll go ahead and check our answer. Okay, great. So I'm going to go ahead and get this out of here. So this one shows us a chart now. So we're going to have to read the chart. And we see that the time interval is 2 seconds. We see the velocity change. It starts at 24 meters per second to the right, and it ends at 8 meters per second to the right. So if we're calculating acceleration, we want to do our final velocity, 8 meters per second, minus the initial velocity, which is 24 meters per second, divided by the time interval, which is 2 seconds. Okay. So this means that it's going to be negative 16 meters per second squared over 2 seconds, which is going to come out to be negative 8 meters per second squared. Now, once again, we're not going to include the negative sign on this particular exercise because we are going to identify the direction based on what it has told us. It says that the object is moving to the right. We know that it's slowing down. So the direction of the acceleration must be to the left. The magnitude of the acceleration is 8. Okay, so remember, the negative sign just tells us direction. So in this case, we are identifying the direction as either left or right, so we do not need to include the negative sign. If this were a math problem and you were actually solving for this and putting it down like on a quiz or a test, and I didn't give you a left or right direction, then you would have to leave the negative sign in there. Okay. So we'll go ahead and erase this, and we'll do one more example here, and then you guys can continue on your own. Okay, so this one says it is a rightward moving car. So this car is moving this direction. And it does tell us that the time interval is 2.5 seconds because it goes from 0 seconds to 2.5. And then it goes from 2 meters per second to 12 meters per second. So it is an increase in velocity. So the acceleration here is going to be equal to the final velocity, 12, minus initial velocity, 2 meters per second, divided by the time interval, which is 2.5 seconds. So that means that our acceleration is going to be 10 meters per second divided by, not sure why I did two equal signs there, divided by 2.5 seconds. So that means that the acceleration is going to be 4 meters per second squared. So our magnitude here is 4. And then we need to figure out the direction. It says that the object is moving to the right, and we know that the object is speeding up. So that means that the acceleration will also be to the right. Okay, so I will go ahead and leave you with that because we've done pretty much one example of each type on this. You guys can figure out the rest on your own. If you have any questions, make sure to let me know.